Students, today we're going to do ItsElemental 2. We're going to take some of our knowledge that we learned last week in our ItsElemental 1, and we are going to see which antacid is the most effective. And what we mean by effectiveness is how many milliliters of acid does it neutralize per gram. And we're going to try brand name Gaviscon, and we're going to try brand name Phillips, and then we're going to do the off-brand Kroger, which also in past experiments has been the same as Rolaids and Tums and like CVS brand. Most of those have the same formula that they use. Okay, so when you feel bad, you feel acidy stomach, it's really quite interesting because your stomach acid is at a pH of 1.5. Remember on the pH, we had the pH scale, and we said that water at 7 is neutral. Okay, and then we said A comes before B, so acids are the lower numbers and bases are the higher numbers. Okay. Your stomach acid is at a pH of 1.5, which is extremely acidic. I mean, that could literally, eat through things. That's so acidic. Your stomach, fortunately, has a mucus layer that covers the stomach. The stomach has a structure and a function that go along with what its purpose is to take your food and to get it into what we call chyme, to get it all ready for your intestines where all the nutrients are absorbed. The stomach has a pH of 1.5. Now, when you have a sour stomach or a sore stomach, that means it's even more acidic. That means the pH is less than 1.5, which is really, really bad, okay? And so you take an antacid, which is some kind of base. You take a pill, and that is going to bring you back to a 1.5. Do you want to take so many that your stomach acid gets up to a 7? No, because part of the function of the stomach is also protecting you from bad stuff that might be on your food. It's going to basically kill or denature everything that comes down there that could cause you harm, almost everything. Okay, so your stomach has a very low pH, but sometimes it gets even lower and you get a stomach ache and now you want some relief, and so you take an antacid. So we're going to test these 3, and we usually test 5 because there's 5 tables and 1 per table, but that would be a lot of extra work. I already know that the Kroger, CVS, Tums, Rolaids, those are all basically just around the same effectiveness. Milliliters of acid neutralized per gram. Okay? So why don't we start with, we'll start with Phillips. And there's 2 tablets per dose, and it is literally $9.99 for 100 tablets. So that's kind of easy math for you. There's 2 tablets per dose. So at one point you have to figure out what is the cost per dose. So we have $9.99, which is the same as 999 pennies. And I like to do it that way just because it's easier in the end. You don't get a strange number. So we have 999 cents pays for 100 tabs. Oops. For 100 tabs. And we have 2 tabs per dose. And so we end up doing the math, and we end up with 9.9, it's about, 18 cents per dose? Let's see. I should have done this beforehand. 1 and 50, and I need a calculator. And so when we do the math, we end up with whatever. Let's do the Kroger. We have 199 cents for 72 tabs times 2 tabs per dose. And that's going to give us the cents per dose. So the first one was 19.98 cents per dose. 19.98 cents per dose. Okay. This is called dimensional analysis. Okay. And the Kroger, we have 199 cents per 72 tabs, 2 tabs per dose. So the cents per dose on the Kroger is 5.53 cents per dose. And so I'm going to let you figure out the one for Gaviscon, which is very close. You should be very close to the Phillips. Okay? So that's how you figure out how many cents per dose. So you can already see that the Kroger is about 1/4 of the cost. Okay? So one of the parts of your data table, you're going to put in the cents per dose. Okay? That's the cost. Now, we want to get the effectiveness, which is milliliters per gram. So in order to do that, we need to pretty much know how many grams are in our tablets. So we're going to start with our Phillips. Now, I just put the weigh boat in, and I'm going to press this tare button. So now it's only going to measure the mass of the tablets. Okay? So the mass of these 2 tablets, 1.13 grams. I'm going to put those in the first mortar and pestle. I'm going to measure the next. Again, we're tearing it out. The next 2 weigh 1.14 grams. Very good quality control with Phillips. And the next 2, 1.14 grams. Now, why are we doing 3 trials? Okay. In science, we like to have at least 3 trials in our experiments because it's important in case, let's say one of these tablets somehow didn't get much of the active ingredient. If we only do 1 trial and we happen to use the batch that didn't get much of the active ingredient, then we wouldn't get good results. So we usually do 3 trials on everything because that's good experimental design. And I want to keep these in order because, remember, one of them weighed a little bit less. Okay. So I've crushed them. Now it smells nice and minty. These are chewable. And the active ingredient is just a very tiny portion of the whole pill. Okay? If all of our medicines were just active ingredients, they would be so microscopic. But they put fillers in. They put sugar and starch and other fillers to make the tablet at a decent size. Now what we're supposed to do is take and pour this into our flask. And then we're going to use 100 mils of water. We're going to look at that meniscus. We're going to see how that glass kind of hugs the, or how the water hugs the glass. And we want 100 mils. We want that 100 mils right at the line, which is where it is. I'm going to pour some in here to get this, and then I'm going to pour it in here. Make sure we don't leave any, but believe me, the active ingredient is already in that container. Okay? So now we've kind of got a slurry here. Okay? And we need to add an indicator to our slurry. So what we have in here is our 2 tablets, which weighed 1.13 grams. We're going to put, I believe it's 10 drops of methyl orange, which is again an indicator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, indicators are substances that we use to, we're going to get this from an orange color to a pink color. When it gets to the pink color, we'll know that we've reached our prescribed pH. We've reached our endpoint. So this is called a titration. We are going to add acid to our base. Now, in our stomach, the acid is in our stomach, and we add the base by eating our antacid. This is kind of backwards, okay? We are adding acid to the base. But when we take an antacid pill, we're actually adding base into our stomach to bring that pH back to the 1.5, which is where we need it, instead of it burns when it goes below that. It gives us discomfort, and that's why we'll take an antacid. You know, when you've eaten super spicy food, or you've eaten you know, too much acidic food or whatever. Okay, we are going to perform a titration, which is just adding a substance to another substance until we reach our endpoint. Our endpoint is a pink color. Okay, so we are starting with at 0 mils, and now we're going to add, and you'll notice that as it strikes, it turns pink. And we've already gotten a pink color. Wow. It did not take much acid at all. Okay. 2.1 milliliters on that first one. Okay. 2.1 milliliters was all it took. And now we're going to do our second one. We will pour it into another. And believe me, I was not expecting it to change that fast. So I'm going to do this one a little more carefully, just to add a milliliter at a time. Again, I'm adding 100 mils of distilled water. Oh boy, look at what's happened. This has actually gone back to orange, and so I haven't reached my endpoint yet, because what was just happening is it was changing color just because what I was adding. We've got it back to pink again. So forget that 2.1 that I told you. Let's let it sit for a minute and see if it changes back or not. If it doesn't change back, then we'll know we've reached our point. Now, after a certain amount of time, because of interactions with the air and other things, it will definitely go back. We want it to persist for, I think, our lab says we want it to persist for, I believe it's 30 seconds after swirling. Okay, so that definitely did not persist for 30 seconds yet. So let's add some more. I might need a tiny bit more. Whoops. Okay. I think we are almost there, because what's happening is that as that acid hits the antacid, where it hits is being neutralized. But we've got to make sure that the whole solution, and we're not getting actually to a pH of 7, we're getting to a pH of around 4 when the color change happens. What we're trying to see is which of these is most effective. In other words, which one is going to neutralize the most milligrams of acid per gram of antacid. Okay. I don't think we're quite there yet. We've got a little bit more to go. Okay, this looks like we might have reached our endpoint of our titration. Again, titration, we're adding a certain substance, in this case acid, to another substance, in this case a base, till we get the desired effect. And we've determined this desired effect with this particular indicator. We're going to get this pink color to persist for 30 seconds. I think we've reached it. And so we have 1, 2, 3, 4. We have 4 point. We actually have 5 milliliters of acid. Okay, so this took 5 milliliters of acid. Again, you see all that crud at the bottom. That's just the filler. That's starches and other things they add to our pills so that our pills aren't so tiny that we would just drop them or lose them. Okay, we're going to add 10 drops to this one. This is, again, an indicator. You can make indicators out of purple cabbage if you want. Indicators are usually a plant-based material. And again, they turn different colors in different acidities. So a purple cabbage one is really cool if you ever feel like doing some experimenting in the kitchen. All right, so now we're starting at 5 milliliters. So if we get to 10, that means we've added 5 more. So this time our initial is 5. Okay, we're getting that pink color. We started at 1, 2, 3, 4. This is persisting for quite some time. Okay, it's going back, so I'm going to add a little bit more. Okay, that looks like it might stay there. So far I've added only 1.5 mils, so I'm not quite sure. Looks like it's going back to that orange. We needed a little pink. Now looking at this one, it has totally gone back, but we only need 30 seconds, okay? It's interacting with a lot of other things right now. Let's see if this one will stay. This was the one that weighed 1.14 grams. All right, it looks like this is going to stay pink. And guys, I made a mistake on the first reading. Now I see the numbers, so you probably saw that. This is at 4. The first one was 4.0, okay? Now we started at 4.0, and we got to 6.5. So the second one, we did 2.5 milliliters, okay? So trial 1, we did 4.0 milliliters, and that was the one that weighed 1.13 grams. Trial 2, what did I just say we did? 2.5 milliliters because we ended at 6.0, and that one weighed 1.14 grams. And now we're going to do trial 3, and this is just for the Phillips, okay? It definitely persisted. So let's try the third. And again, this is why we do 3 trials. If you look at the difference is quite a lot. So hopefully this one will go right in between those two. But let's see. We've got another 100 mils. Again, the active ingredient is definitely in solution. You don't have to worry that there's a few crumbs in here because those are just what we call the fillers, the flavoring and the starches to make our pills larger. Okay, we're going to add our 10 drops. Now again, remember we are at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember we are at 6.5 at this point. So our starting point is 6.5. Again, the end point of this titration isn't neutral 7, but it's, I forget where methyl orange changes. People use different indicators for different reasons. There's Bloom-Thymo blue, which we'll use in a different lab. Like I say, you can make it out of cabbage. Lots of different indicators for different endpoints. And this whole process we are titrating right now. We're trying to determine the effectiveness of this particular brand of antacid. Okay. That did not persist. Again, we started at 6.5. Well, let's see. This might be persisting for 30 seconds. Now, a little bit more maybe. This may be it. Okay. We went from 6.5. Okay. So we went from 6.5 to 9.0. Yeah, we'll have to give it a tiny bit more. That should do it. Okay. So it looks like, yeah, might need a dab more. This 30-second thing, it's a little, you can see the other two have completely changed back. Again, because of interactions. Yeah, this one looks like it will persist. Okay, so we started at 6.5. I'm going to come around to read it. And we ended at 9.6. So 6.5 minus 9.6, or 9.6 minus 6.5 is 3.1 milliliters per 1.14 grams. Okay. These are our 3 trials for Phillips. Okay. Our 3 trials for Phillips. 4.0 for 1.13, 2.5, 1.14, 3.11. So now you are going to do the math. Okay. Remember, effectiveness, milliliters per gram. You're going to do the math. You're going to find the average effectiveness. So do each of these. Okay. And add those together and divide by 3. That will give you the overall effectiveness of the Phillips. Okay. All right. So what we need to do is get our next antacid, which, why don't we do the Kroger one? And I am going to give each of these a rinse to make sure we get all the other thing off. Get all the other antacid out of there. And we'll just pour those right into the other container. Now again, each table would be doing this. I'm going to rinse, I'm going to soak that, or dry it out as well. You can see I'm not that great at pouring right now. And I will dry these off. Okay, so let's do our measurement on our Kroger antacids. Again, 2 tablets per dose. Okay, I'm again going to use the weigh boat. Okay, I guess it zeroed itself out. So let's zero it out again. All right, 2 tablets. First dose, 4.87 grams. Okay, 4.87 grams. 4.88 grams. You can see these tablets are a little bit larger, but it's really the active ingredient that matters. 4.90 grams. Okay, so we've got a new antacid. Now we're going to grind it up again. Again, the active ingredient is a very small part of this. I once taught with a guy when I used to teach middle school. All he did was pop these antacids all day, and you know, it was really not good. If your job is so stressful for you that you just have to pop some pills all day to get through it, then it might be time for a different job. Okay. Unless you're in a pandemic, right? Okay, that's good. This one's a little bit full, so I'll put that in extra into here. So again, we're going to use 100 mils of distilled water. What we're looking for is the milliliters per gram of acid neutralized. Okay, got to make sure I use the distilled water and not the hydrochloric acid. That would not be a good mistake to make here. So we've got our 100 mils. A little bit too much. And now we're going to add to our new container. And we've got a lot of powder on this, on the pestle. And you can tell this one is just loaded with fillers. Now, you got to believe me that the actual active ingredient is dissolved in the water. The Kroger one smells very minty. It's also loaded with fillers. We'll try and get as much out of here as we can, but believe me when I tell you the active ingredient is in the water. Okay. Okay, now we're going to add our 10 mils, or 10 drops of the indicator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And I am just going to fill up, this. Now the fill-ups, we did all 3 trials, and it basically only got down to 9.6. So let's see how we do on this one here. Let's start it back at 0. Okay. So we got that meniscus just hugging right at 0. All right, so now we start our titration. Again, we're adding acid to the base. When you do it, you add base to the acid. Your stomach is too acidy, so you're eating a base. You can see that this one is neutralizing a lot of acid. We're already at 10, whereas all 3 trials of the Phillips took this long. So what would you say of the effectiveness? Well, these weighed a little bit more. Wow, I'm already down to 14. I am down to like 16. So which one is probably more effective? Well, this is definitely neutralizing a lot of acid. Now remember, you got to take the grams into consideration. So when you do your effectiveness measure, you're going to have to divide whatever these milliliters end up being, which we've already drained. Woohoo! We've already practically drained this entire burette of acid. And we haven't even reached the end point. So far we've used 25 mils. What do you think about the effectiveness? We can't know until we measure the milliliters per gram. Okay, the milliliters per gram. So we've got 25. It's getting a little pinker. It's persisting for a little bit. 25. Wow. Even with the larger size pill, even dividing by a bigger number of grams, we're using, this is neutralizing so much acid. Look at that. It's probably going to have a much greater effectiveness. Wow. Okay. Okay. Oh, that looks like we might have reached the end point. It's staying pink. Let's give it about 30 seconds. Yeah, it's actually going back, isn't it? Give it another shot. Look at all that filler in there. Wow. Okay, that one may be persisting. Okay, we are at 13. Yeah, it looks like, I think it might need a little bit more. Now I think it's going to stay pink. So we had 25. Now we are down to, I believe, 14. Let me just check. Okay, 13.5. So 25. Oh, it's still not persisting, is it? Okay. So that one is 25 plus 14, 39 milliliters. Okay, 39 milliliters. 39 milliliters. And I don't remember the grams, but you got that on the video, so. Now, what I'm going to do to speed this up a little is I'm going to do this experiment 2 times more, not on film, because our camera guy needs to get going. And what we're going to do is I will give you that data in the lab for the next 2 trials. And we're going to now do the Gaviscon. Okay, we're going to do the Gaviscon one. We're going to do 1 trial of Gaviscon on film, and then I'll do the other 2 trials off film. So I'm going to do 2 Gaviscons. And again, I'm going to do all 3 trials, and I will tell you the results of those. 3.23 grams for the Gaviscon, 3.23 grams. Okay. I am going to crush it again. Okay. And again, I'm going to give you the data for the other 2 trials, so you will still need that data. And I need the 100 mils of water, which I already pre-poured, so that's good. Okay. And let's get that into our flask. Okay. again, all that stuff floating around is filler. Okay, the active ingredient is definitely in the solution. Okay, I'm going to just use this to stir. Look at that one. This one almost smells like butterscotch. Okay, almost smells like butterscotch. And again, I've got all this inside, but I'm going to just pour this back into here. Hopefully I'll get a little bit more out. But trust me, whoops, the active ingredient is in there. Okay, it's in the water. Okay, let's put our 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This literally smells like butterscotch. Okay, now we are at 14, and I'm going to just add, okay, we're at 14.0. Now this is the most expensive one. We started at 14.0. We've added 1 ml so far. .5 mils. Looks like it's about persisting. What do you think about Gaviscon? 1.5 mils, and it's already close to the end point. We started at 14. Looks like we may be at the end point at 15.9. I did spill a tiny bit, I have to admit, but I know from previous that Gaviscon is the worst. I had a student whose dad would eat literally a container of Gaviscon every day. I mean, that again, if you have a job that's stressful, you need to find a new job. But when he saw how ineffective Gaviscon is, then kind of understood why he needed to get so many. So we started at 14, we're at 16. Okay, so the name brand, the most expensive, let's see where we get to. So far we're at 16.7. We started at 14, so we're at 2.7, but remember this pill weighed more than Phillips too. So it looks like we reached the end point. I'm going to add just 1 more drop to see if it goes pink. Okay. And I just don't think I can get it pinker because the filler is blacking. So you really, even if I add a little more, it doesn't get pinker because there's so much filler. So we started at 14, we got to 17.3. So it's 3.3 milliliters. And this was the Gaviscon. Okay, 3.3 milliliters. Okay, so I'm going to do this experiment with the Kroger 2 more times. I'll put that data up. I'm going to do the experiment with the Gaviscon 2 more times. I'll put that data up. And what you're going to do is you're going to determine the effectiveness of these various antacids. Now, you're going to present your data in a number of ways. There are different categories you can choose. This student chose milliliters per cost, or milliliters per penny. So they took the number of milliliters in their average per cost of the antacid and graphed that. This one did effectiveness, milliliters per gram. You can see, like I told you before, that the CVS or Kroger brand, the Tums and the Rolaids were all very close. Look at the Gaviscon way down there. This was in previous classes. Okay, here's another one. You can do your graph. This is another cost per dose. This is another milliliters per gram. Some students like to do three different, they did volume per dose, volume per cost, volume per mass. You choose whatever category you would like. Now, you're going to make an ad for your antacid as well, okay? An advertisement. So if you choose cost, then your advertisement is going to be all about cost. If you choose effectiveness, your advertisement's going to be all about effectiveness. So that's part of the lab as well. Okay? Now let's look at the questions real quick. You're going to be doing the math. It says the first question, commercial claims that since each tablet neutralizes 10 mils and one neutralizes 20, then the one with 10 must be better. Why or why not is that true? Number 2, how would you determine the effectiveness of an antacid tablet the size of this building? You have to remember that effectiveness is milliliters per gram. So the whole building, think about it. Does it matter? It's milliliters per gram. That's all I'm going to tell you about that one. Question 3, as long as your answer makes sense to me, I'm going to count it okay. You have to kind of go through and figure out in that one. Question 4. Now this is going to determine whether you get, a great grade on this lab or an average grade. You're going to tell me everything you know about acids and bases from this week and last week. And I want everything you know, okay? And how does this relate to the titration we just did? Remember, we're adding hydrochloric acid. We're adding H plus to a base. Most of our bases had OH minuses. Here are the effective ingredients. But the carbonates also are bases, okay? Think about the H and OH making water, okay? When you use a carbonate, the H, what you end up with carbon dioxide. Some of these make you belch. Some of them make water and neutralize that way. Some of them make carbon dioxide come out and you end up belching it out. Okay. The next question is your ad, and you're going to make a graph, and then you're going to actually write your ad out. Okay. That's the whole lab, and again, I'll put the rest of the data up. Thanks.